Hello everyone, welcome back to the channel. Now in this video we are going to implement a traversal algorithm for graph. So before we do that, let me tell you how is it different from the traversal that we did in tree. Okay, so in trees we used to have a root node, right? But in graph we don't have any of such node as root. We just select a root and consider that that is a root node and start traversing from that particular node. So that's what I have written here. We choose a node, you start traversing from that node. All nodes in the graph might not be reachable from that node. So what that means, you choose a node, you consider that particular node as root node. When you start traversing, that node might not be connected to all the other nodes from the graph. So in that case, you won't be able to print all the nodes. So that's what I'm trying to explain here. That is a condition, and it's possible that you might not be able to trace all the nodes. And here also you have same those similar algorithms, which is DFS and BFS. We are going to implement them one by one to understand what is happening. So just to give you an overview, if you're implementing this DFS, right, let's say your nodes are connected, right, A to B, B to C, C to D. So first it will try to reach till depth, that means till the last node, which node does not have any other nodes connected to it. So it will go till that particular depth, it will print all the nodes all the way, and then it will start checking for the other branch. Now that's what happens in DFS. In BFS, what happens, we make use of queue data structure. You take a particular root node. When you add that particular node, right, you add its adjacent, that means the neighbors of that particular node. Whenever you add the node which is next in the removal in the queue, you add the adjacent node for that particular node, and this you continue on, keep on doing until your queue becomes empty. So that's when you can say you are able to traverse the complete graph. Now here we are going to implement DFS, that too in a recursive manner. So let's go ahead and implement that. So let's implement this method and see how this traversal is happening. Now this we are considering as root. So if, first of all, before you go ahead and check anything, first thing that you check, if this node that you're trying to traverse from, right, it even exists or not. If this node is equal to null, that means it does not exist, right, there is no point of going ahead and you return the control there itself, or else you write your recursive method which is going to take your node, and which is actually a root node that you have taken just now, and a new hash set. Now why you're taking this hash set? The reason for taking this hash set is so that whenever you are going through this recursive method, the node that you already traversed, right, that you don't want to traverse again, right? That means that is a unique traversal, and whenever you want to keep track of unique values, you make use of hash set. Okay, hash set is a data structure which can store only unique values. Okay, there is no possibility of having duplicates. So whatever nodes we are visiting, right, to keep track of them, we are going to make use of this hash set. Now let's implement this method as well. Now when you get into this recursive method, first thing that you want to do, you want to print the node that you are visiting right now, which is the root node, and then you want to add the same node to your visited set. So visited dot add that particular node. Now once you have added the node to the visited set, all you're supposed to do, you're supposed to call the same method in a recursive manner, so you can go till depth and you can traverse till the last node which is connected. So how do you do that? You get a graph node. Now for each of the node which you're getting from adjacency list dot root, what you're supposed to do, you are going to check if this visited does not contains this particular node, that means you haven't visited that particular node, then you're supposed to visit it. And how do you write that visited logic? You're supposed to pass that node and with the node what you're supposed to pass the set of visited, and that's it. So what you're doing, you are getting the root, okay, and this will basically return the list of the nodes which are there for that particular node, right, which is basically neighbors of that particular node which are connected to that particular node. It will return that, and for each of those nodes it is checking if you already visited that particular node or not, and if you have visited it will just skip it. If you have not visited it, that means it does not contains that particular node. In that case you're going to visit it, and how you're going to visit it, you're going to pass that node and the visited set. And let's go ahead and run our program to check if we are able to get this answer or not. A is connected to B first, okay. Now A is connected to B, we have printed B. Now B is connected to D, we have printed D. Then now D is connected to C, and then we have printed C. So A, B, D, C, it went till the last node which is connected in order. So that's how your depth first traversal work. That means our algorithm that we have written is working perfectly fine. Again, just to summarize this, what we have done, we have picked our root node, which is A in our case. We have got to know that root node is valid or not. Once it was valid, we pass that particular root node and the hash set where we are keeping track of the visited nodes. Then in our recursive method, we have printed the particular root node value. We have added that particular node to our visited set, and then for each of the node from the list that we are getting from this root node, what we are doing, if we haven't visited that particular node already, we are traversing it again, and then we are adding that particular node, and then we are adding to the visited set. That's all we are doing, and that's how we are able to get the answer. So that's how you do, depth first traversal in a recursive way in a graph. So that's all as part of this video. See you in the next one.